look at the data that we're seeing here, right? So on day one, you're at 0. There's no moon, right? The moon is dark. On day 4, it's up to 10%, and so on and so forth. You can read the table for yourself. Then they give you a graph. We don't always have the graph, right? But in this case, we do have a graph. The graph seems to start out somewhere here, goes up to a peak, and then it comes back down somewhere over here. So our goal now is to find a sine and a cosine equation. Let's just focus on the data for a bit. If I said to you that this represents the data, forget the graph for a minute. This just represents data. Starting on day 1, then it eventually goes to day 29, where you're back at where you started from. If I asked you for the amplitude of this function, what would you say is the amplitude function? I've given you a way that you can get that value of A. I've given you a formula that allows you to find the value of A. I don't know if anybody remembers that. How can I find the A in this case? You can put it in the chat because, for some reason, I can't record your voices. So we're going to have to do this entirely by chat today. So can anybody remind me how we can get the amplitude of this function? Looking at the data, is there some way? So high minus low divided by 2. Well done, Emily. Right? And by the way, let's just make sure we're clear on this. When we're talking about the high minus low, we're talking about the y values, not the x values. So the top row here represents my x values. The bottom row represents my y values. So Emily is right. Look at what Emily just put into the chat. She says high minus low divided by 2. So what I'm saying to you is this. We know what the high is in this case. It's 100. We know what the low is. 0. What would the A be based on what Emily just put in? It would be 50. So we can start by writing that the A is equal to 50. That's my A in this case. The other thing that I always like to go to is the vertical translation. Does anybody remember? Thank you, Jeremiah, and thank you, Archana. Thank you, Elizabeth. Does anybody remember? There's a related way to get the C. Has to do with the high and the low again. This time it's the high plus the low divided by 2. Excellent. So what would that be in this case? The high plus the low divided by 2. What is that in this case? It's also 50. Thank you, Elizabeth. So the C and the A are the same. That's not always the case, as you well know. All right. So, okay, we have the A, we have the C. Now, let's see if we can come up with the period. Now, remember, the period is not the same thing as the K, but it has an influence on the K. Let's go back to the data again and see if we can figure out what the period of this function might be. How long is it taking for us to complete a cycle? Okay, I see one answer there from Sharisa. If everybody agrees with that, or is there a different answer? Okay, Jeremiah says 28 and Sharisa says 29. What do other people think? I'm not weighing in yet. I'm just asking for people's opinion on this. All right. What would the period of this? Okay, Harish is on the same page as Jeremy. Anybody else? Okay, Archana, Karis, interesting. It is actually 28. And thank you for all those responses, by the way. Okay, and that's because to get from the low, which is at 0, to the next low, which is at 29, the difference between those two x values, which would be the period. Remember, the period measures horizontally. So you look at your x values to get the period, right? The amplitude measures vertically, and that's why I look at your y values to get the amplitude. So looking at the x values now, the difference between the high and the low, right? The high occur, sorry, not the high and the low, between the start and end of the cycle. So it started at 0, ended at 0, and the number of days between 29 and 1 is 8. So the period is actually 28 days. In fact, I'll put the unit there as well. All right, we're talking about days here. All right, how about the k then? All right, so we don't put the period into the function. We use the k value for the function. So does anybody know what the k should be? Pi over 14. In other words, it's 2 pi divided by the 28, which, yes, reduces down to pi over 14. Okay? Now, the next question is, how do we come up with a D, which is to say, how do we come up with a phase shift, what we call the phase shift? It always depends on which function you're trying to write. Am I trying to write a sine function or a cosine function? Here's my thought on that. I think if you have the data and you're able to see the high point from the data, I think you should try to write a cosine function, right? I think it's easy to write a cosine function. If you need to, you can easily change it to a sine function after that. But my take on it, and we may hear a different approach from a different teacher. My take is that you should try to write a cosine function because it's fairly easy for you to figure out how far to shift to get to the high point and use that as your phase shift, right? If you're trying to write a sine function, then you have to put in the center line and ask, where is the function intersecting the center line? And that's not always easy. So I say, my view is that we should write it as a cosine function. And then if we're asked to write a sine function, then transform it to a sine function using that technique that we learned last week. So if that is the case, my D, right, which is the phase shift, is how far did I shift the high point from the y-axis, right? How far did I shift it from the y-axis? How far do I have to go along the x-axis to get to that high point? So looking at the table, look at the table now. Looking at the table, can anybody answer that question? How far along the x-axis do I have to shift? It would be 15. Thank you very much. So 15 to the right. So here's what I'm going to do now. Is I have everything I need to write my cosine equation. Write my cosine equation. Actually, let me move this whole thing up here. 1 second. And let's move all of this stuff up as well. Okay, I'm ready to write my cosine equation. So here's my cosine equation. Y is equal to 50 cosine pi over 14 x minus 15 plus 50. We're going to do two things. First of all, we're going to write the corresponding sine function, and then we're going to put it on that Desmos graph that we told, which is why I said I'm recording the entire screen. I'm going to put it on that Desmos graph afterwards. So for us to be able to write a let me remind you now, for us to be able to write a corresponding sine function, we have to add a quarter period to our cosine function. Our cosine function right now, it says x minus 15. What is a quarter of the period that we're talking about now? We have the period as being 28, as you can see. What's a quarter of that? What's a quarter of 28? Come on, folks, that's a very simple question there. 7, thank you very much. So x minus 15 plus 7, which of course would be x minus 8. So I'm going to write my sine function now, which would be that y equals, it's still 50, but now it's sine, it's still pi over 14, but now it's x minus 8, and then plus 50. Okay? Down here, we're going to use our equations to determine the potential elimination on day 6. We'll do that first before we put this onto the graph. The table doesn't tell us anything about day 6. It tells us that on day 1 it's this, on day 4 it's that, then day 8 goes from 4 across to 8. But it doesn't tell us what happens on day 6. Now we can assume, a reasonable assumption is that it's going to be somewhere between 10 and 50, because in jumping from 4 to 8, somewhere right in the middle is where day 6 would be, and therefore it should be somewhere between 10 and 50. But if we have equations, could our equations give us something more accurate, right? If we're going to model it using this equation, can we use the equation to figure out what's happening on day 6. Jeremy, put it in the text for me, please. I believe it would. I believe if you were to speak, it would end up in the recording, and I prefer if you just put it in text for today. It's just one of those things that they ask us not to do when we're having or when I'm recording the session. So put it in text for me. Tell me what you think I need to do to figure out what happens on day 6. The illumination, the percent illumination for day 6. Substitute y equals 6 or x equals 6, and absolutely, that's exactly what we're going to do. So does it matter which equation we use for that? Does anybody think it matters which equation we use? Is there a better equation to use? It does not matter. We should, if these equations are in fact equivalent in the way that they behave, we should get the same answer for both. So since the sine equation is the one that's still in view, I'm just going to use the sine equation. So grab your calculators and let's put that together. Y is equal to 50 sine pi over 14. The x we said was 6 minus 8, close bracket, plus 50. Okay, so you all have your calculators there. Go ahead, tell us what that number is. And then one of the things I like to do when I was a student is to make sure my answer is reasonable. Based on the table, my answer should be somewhere between 10 and 50 because 6 is somewhere between 4 and 8. So my y value should be somewhere between 10 and 50, almost like halfway between those two. Not exactly halfway, but kind of like halfway between those two. So when I put this in the calculator, if I'm not getting an answer that is kind of somewhere between 10 and 50, I made a mistake somewhere, either in terms of the equation or entering it onto my calculator. So folks, over to you. Get your calculator fingers ready and working. Put the 6 into the function. So it's 50 sine pi over 14 of minus 2, essentially, because 6 minus 8 is minus 2, and then plus 50. Let me hear some responses to that. What would the percent illumination be? Okay, so I'm getting people saying 28.3, and everybody's saying 28.3. So I'm going to actually put that down. 28.3%. That's approximately equal to 28.3%. And that answer makes sense because look at what we said. Our answer is between 10 and 50. Well, 28.3 is absolutely within that particular region. So we should accept that as being reasonable. Okay, so here's the next thing we're going to do now. We're going to get some practice with using Desmos to put a scatter plot. This thing that we're looking at here, you remember this from grade 9 probably, is what's called a scatter plot. So it's taking the data and putting discrete points together on the data, and then we'll put the equation into the Desmos as well, and hopefully get the equation, the line that's generated from the equation to match up with the dots. Will it be perfect? It's not necessarily going to be perfect. Let me just say something about that. The world is not a perfect place. You've all been in it long enough to know that it's not. Okay? When you go out and you collect data, one of two things can happen. One is that you may make an error when you're collecting data. Will we use the same scatterplot Desmos for a test? Yes, you will actually, and I'll tell you how you can do that and include your answer from Desmos in the test. I'll get to that. But anyway, you know that when you go out and you collect data, sometimes your data is wrong. You made an error in collecting the data. That's one. Two, the other thing is that Mother Nature doesn't always behave the way you want Mother Nature to behave. You know this. You make a prediction based on the best science that you have out there. Right? You've studied the phenomenon and you think you have this nailed down and you create a model, and Mother Nature does a 180 and says, okay, that's fine with your model, but I'm not here to obey your rules. I'm going to do what I want. Okay? So the fact is that models that we create as human beings to try to sort of interpret and to predict what happens in the real world aren't always perfect. So whenever you see that you've done a scatter plot and you put it together with your model, you're going to find that some dots don't line up as nice as you'd like them to. That's just the way that goes. So what I'm going to do now is I'm going to open up my Desmos. I'm going to ask you to do the same thing. Get a Desmos screen going. So I'm going to come over here, move that out of the way, open up my Desmos. In fact, I don't need that. I'm going to delete it. You're all probably hopefully seeing my Desmos screen. And what we're going to do is we're going to put our points in to a table which will create the scatter plot. Okay? So you somehow need to be able to see the data from the table. Now that's going to be a little tricky, but I'll show the data from the table in a minute. I'm going to show you how to add that. So if you go to that plus sign that you see in the top left-hand corner, where it says add item, where you hopefully can see where I'm pointing my mouse right now. If you click on that, there's one of the options that says table. So do that first, please. Start with that. All right, everybody do that for me now on there. So having a separate tab going with the Desmos screen. Okay. I need to switch back because I need all my X values. My X values are 1, 4, 8, 11, 15. I'm going to write them down because I'm going to need them for putting them into. You might want to write these down because you need these values to put them into your table. So I'm going to put these. I'm just going to, or screenshot it, one or the other. It's up to you. I'm going to go ahead and just simply copy down these values. So it goes from 1 to 4 to 8 to 11 to 15 to 19, 22, 26, and 29. Most of them are going up by 4, but not every single one. Not every single one. Anyway, 1 is 0, 10, 50, 80, 100, 80, 58, and 0. Okay, so I just copied all of that down. I'm going to go back to my Desmos screen now. I'm going to start putting in my X values first of all. Are we supposed to be see the table? No. Oh, I'm sorry. I thought I just put the table up a while ago. Hold on. Can you not see the table that I was copying down? Jeremy, can you see my table now? I would take those values down. Okay. So I'm copying the table because I want to put that table of values into Desmos. I'm going to go back now over to Desmos and start putting my values in. All right. So let me go back to Desmos now. So my X column is my first column, and I'm going to start, well, actually, I need my keyboard for this. I'm going to start by entering my X values. So the first value, of course, is 1. It's going to go down, and I'm going to go to 4. Now, Desmos has a way of trying to predict what you're going to do next. You see it's trying to put in 7, because it said, okay, it went from 1 to 4, which is a jump of 3. But the truth is that we need to put in 8. So I'm going to put in 8. I know Desmos is trying to help us out, but that's not what we want. And then 11, and then 15. If you want to use my table as I'm putting it in to do the same thing, and then 19, 22, 26, and 29. So those are all my X values. So here come my Y values, which would be 0, 10, 50. You should be doing the same thing at the same time. 80, 100, 80, 50, 8, and 0. Okay, I believe I have those all in now. Now, the only issue is to make sure I can see that on my graph. So I'm going to close up that table. The values are still there. My table values are still there. But I know that my x-axis needs to go at least to 29. So let me just move this over a bit here. Move this over. And then also, because I don't need the negative side of the x-axis at all. I'm going to change my y scale. So you saw where I went to the little wrench in the top corner. I'm going to change my my x-axis. I need my x-axis to go to at least 29, if not more. I put 30, right? And then on my x-axis, I know I need to get up to 100. So I'm going to put maybe 100. And I don't want to just make it exactly equal to 100. I'm going to make it 120. Okay. So what you'll notice is that I now can kind of see the points that I put in. And you should be able to see them as well in your graph, right? You can change the color of the dots if you don't like the color that it is. That's pretty easy to change. But I mean, it doesn't really matter, seriously. So there we go, folks. I'm going to zoom out a bit here. All right, so there are the points in my scatter plot. Is everybody Is everybody managing so far with this? Is everybody okay with this so far? Has everybody been able to put their table in? Yes, Axel. Okay, great. Jeremiah. Okay, great. All right. Everybody else okay with this? Or do you need me to go over any part of that? Teresa says yes. Okay, good, good, good. Okay. So the next thing is now let's see if our model, which is our equation, worked. Does our equation match up nicely with our graph? So of course, I'm going to go back and I'm going to go below my table where I can put in my equation. So if I remember correctly, it was that y equals, or you don't have to put the y equals actually. It's not absolutely necessary to put the y equals. In fact, I'm just going to skip that part. It was, I'm going to put the cosine one in. I'm going to put both in. Cosine of, to get pi, you just put the word pi. Don't use this square bracket, just use a round bracket. Pi divided by 14. So that's exactly what I just put in. And then I'm going to put another bracket inside of that. X minus 15, I think it was. And then plus 50. I'm missing something. I don't think I put the right A in. I think I left the A out. So 50. Okay. So if you, and I'm going to put in my sine function as well, right? I'm going to put in my sine. I'm going to open up a space below that and put my sine function in. So we said that the sine function was 50, and then sine pi rho. Just put the word pi. Yeah, that's how I got that pi divided by 14. It was x minus 8, I believe, if I remember correctly. And then we had the plus 50. The two lines should be superimposed on each other, right? The red and the black, you can't actually see the red because it's being covered up by the black. Okay, now, hopefully everybody has the same thing I have. You should all be doing this for yourself, right? You should all be doing this for yourself. Now, is our model perfect? It is not. There are a couple of dots here that don't line up exactly. This one here is a little bit under it. This one is even more under it. But I'd say for the most part, we did a reasonable job. Would you say that? I mean, how does yours look? Right? Look at your own graph. First of all, do you have all your dots in place? Right? And secondly, is your model, the model being the equation, is it lining up nicely with the points that you put in? Right? Does the model fit? Yes, it misses up 26, 26. 26 is here. Yes, that is true. All right. That's the one that's probably the most biggest miss right there. There's a way to measure this, by the way, which maybe I should go over that with you. It's called regression analysis to measure how well the model fits the data. And you can get a score for that. Why does that happen, Jeremy says? Remember, Jeremy, I said to you that in the real world, and that's what we're trying to talk about here, in the real world, sometimes either you, when you're collecting your data, you make an error when you're collecting your data. So that's one way. The other way is that Mother Nature, if weather forecasters are famous for this. People who are in economics and are trying to make predictions about the future are also famous for this. You ever notice that when the weatherman is making a prediction, he does models, he uses models, by the way, to predict the weather. The weatherman never says, well, hardly ever says there's a 100% chance of this or that happening. Usually when they're presenting, they'll say there's an 80% chance of snow or rain or whatever, right? Doesn't line up perfect because we data may be, yeah, exactly. So if in the first place, our data may be wrong. We may have made a slight error when we're collecting it. Or the fact is that nature doesn't always obey your rules, your model. It just doesn't, right? So don't expect it to happen, right? When the weatherman is trying to predict what's going to happen in the future, he may be wrong. When the economist is trying to predict where interest rates are going, they may be wrong as well. So the real world doesn't always obey with your model. That's just the way things are. Okay? All right. So is everybody I mean, everybody, I really hope that you're not just looking at the screen, but that you are actually trying this out for yourself, right? And you're hopefully, your two equations are there and that your data is there, your scatter plot is there, and it's all lining up very nicely. Now, the other thing that we should be able to do, that wasn't asked in this question, but the other thing we should be able to do is to say, On what day is illumination approximately 80%? Right? So, let me go back to the actual smartboard question. The question we asked is, right? Where is the question? Usually the illumination is on day 6. What if I ask it a different way? What if I said, which day will it be 80%? Well, there's no 80% in the table. Oh, that's not true. 80% is in the table. What if I wanted to know when it was going to be, let's use another number, 60%, right? How would we do that? What day would that happen? How would we figure that out? Right? What day is the moon going to be illuminated 60%? How would we approach it if we have the equation? Does anybody have an idea? Put it in the chat for me, please, Jeremy. Is there a way that we can do that? Let me hear your thoughts on that. If we just had the equation, yes, correct. Then what do we do with the equation? Set it equal to 60, and then we solve for y. We'd have to solve, just like how we've been solving equations, that's exactly how we would do it. So I'm going to leave that, and another time we can do that. I want to see if we can get on to you trying one of these for your, actually, we'll do one more together first before you try one on your own. Let's look at this table here, right? Everybody focus on in this for a bit. Determine a sine and a cosine equation for this table. Predict a value for x equals 25. Predict the first positive value for when y equals 10, round to the nearest 10. So at some point, we will have to do that, solve that equation that we talked about. Now, let's look at this table. Let me zoom out a bit so that you can see more of it, and then ask you for the A and the C and all that stuff that we talked. We're gonna see if our model works, by the way, because we're gonna go back to Desmos and we're gonna put all this information into Desmos and see if we can get our model to work. Okay? So first things first, let me zoom out to maybe 150%. Can you see everything there? Yeah, more or less. You can see most of it here. Look at that table now. All right, I'm going to go back to my stylus. From 0 up to 15. Gives us a whole bunch of values here. Can anybody tell me what the A is in this case? What is the A in this case? We're going to ask all the same questions we always ask. What's the A? What's the C? What's the period, which will tell us the K? And then we're going to ask, obviously, about the phase shift. Now, the phase shift, let's say the phase shift based on cosine, because I really feel that cosine is the easier one to work with. All right? So, the A. Does anybody have a theory about what the A is in this case? Harish says it is 4.5, 9 over 2. Where is Harish and Joel? Where are they getting that from? Right? Where is that coming from? Anybody know where? Can anybody tell me where that is going? Okay, so Joel has a different answer, by the way. Joel says it's 7.5. So is Joel the one that's right? And the others are wrong. Kayla says it's 4.5. Interesting. So most of you think it's 4.5. Where is that coming from? The 12 minus the 3. So look for the high, which is 12. No, there's no graph here to guide us. Okay? It's not like we can look at a graph and say, oh, hold on, we can either. No, we got to go with the figure in the table. We got the data. We're going to use the data to come up with all of the stuff we need to put an equation together. So we're hearing that the high and the low are 12 and 3, and I agree with that. So if I take that high of 12 minus the low of 3, I'm getting 9. 9 divided by 2 is in fact 4.5. So I'm going to agree with that. Okay. You meant 4.5. Okay, Joel. All right, my bad. Okay, how about the C? What do you think is the value of the C this time? You're thinking 7.5, Emily says. What do other people think? And Jeremy also says 7.5. And Joel also says, and Rachel, and Karis, and Kale. Oh my God. So it looks like 7.5 is the consensus. And of course, what we're doing now is we're adding the 3 and the 12 together and dividing that by 2. So yes, that would be 7.5. Okay. What about the period of the function? Oh, right. What is the period of this function? Does anybody think they know what that is in this case? Harish thinks it's 10. What do other people think? I'm not going to agree or disagree. Jeremy thinks it's 10. No comment. Is there anybody with a different answer? Or does everybody wants to just line up behind Jeremy and Harish? Right? And maybe I'll ask them how they got that answer in a minute, but I want everybody else to come up with an answer for themselves. What is the period of this function? Okay, let me go to Harish. Harish, first of all, I'm going to agree with you. Tell us how you got 10, though. Tell us what you used to come up with 10. 11 minus 1. Why 11 and why? Tell me why you chose 11 minus 1. At the x-axis, why 11? That's what I'm asking. That's exactly what I'm asking. That's exactly what I'm asking. Because I have a different, I did something else. Jeremy, what did you do? 12 minus 2. Why 12 minus 2? Why are you using 12 minus 2? Those are the two highs. That's exactly what I think you should do. If you have the two highs, and we do, let me show you them. I'm going to circle them for you. So here is the high. Here is the other high. Right? That's the point where those two things peaked. Remember that the period is the horizontal distance. So look at your x's now and find out how far apart they are. Kayla did the same thing, right? How far apart are those two highs on the x-axis? So that's why 12 minus 2 makes sense. Now, let's say your data didn't have the two highs. Let's say your data had a high and a low. If that's what you have, then what you could do is take the high and the low, figure out how far apart they are, and then double that to get what the period is. But we do have the two highs here, so I'm going to agree with that as being the period of 10, which means that my k is equal to what? What is the value of my k since the period is 10? What would you say is the k value? Because we need a k for the equation. We can't put the period into the function. What we put is the k value. So what is the k value if the period is 10? Okay, it would be pi over 5 is correct, yes. But is everybody clear on that, by the way? Why it's pi over 5? I want to be sure that everybody's following that. Let me ask a few people here specifically. Let's see. Kristen and also Noah. Kristen and Noah, does that pi over 5 make sense? Could you explain it quickly? I sure can, Isaac. Noah says he's good. And how about Kristen? Kristen, how about you? Does the pi over 5 make sense to you? Where's Kristen? If it doesn't, you need to let me know. Where is Kristen, by the way? Kristen, where are you? Kristen was the one who was absent, was it? No. Okay. So, Kristen, I'm asking you whether what we did, hopefully you've been following along, does the pi over 5 make sense as the k value? Does that make sense as a k value? I need to know if that makes sense to you. Noah says yes, but I just want to be sure that you follow as well. We said the period was 10, and now we're saying the k value is pi over 5. Does that sound about right to you, Kristen? What do you say to that? If you're not sure, then you need to let me know. Kind of, but can we re-explain? Okay, and that's important for you to do, in the class, not just Chris, everybody else. Isaac absolutely came in and said, "Can I explain it again?" And I will, but you need to let me know, like Isaac did. Remember that if you have the period, and then write it down under here. Sorry, I'll write it the other way. The k is equal to. What we're trying to do is get the k. So let me stop this. That the k is always equal to 2 pi divided by the period. In this case, it's 2 pi, therefore, over 10. And that reduces down Isaac and Kristen to pi over 5. Does that make sense now? Okay, and how about you, Isaac? Okay, so there's my k. The other thing is we need to know what the phase shift is for a cosine function. And we're running out of time. So I want us to try to put this table into Desmos in a minute and make sure our equation matches up and all that good stuff. We can come back to it tomorrow. But if it's a cosine equation, what phase shift am I going to require? Look at the data in the table again, right? Can anybody tell me what kind of phase shift is going to make sense based on what I just taught you a few minutes ago for the other table, for the moon thing, right? So Jeremy thinks it sounds like you're saying, excuse me, a little water here. Sounds like you're saying it's a shift of 2 to the right. It sounds like what Jeremy is saying. And does everybody agree with that? Does that make sense? Phase shift is 2 to the right. How do you find the phase shift again, Rachel? Thank you, Rachel. Right, you're doing what I just asked you to do. What I said a few minutes ago is look for the high if you're writing a cosine function. Look for the high, which is at 12 in this case, and ask yourself, how far did you shift it? Okay, Janaya, how far? We've almost finished the class, by the way, so if you want to wait a little bit so that you don't miss what we're doing. How far do I shift to get to that point at 12? How far along the x-axis do I go to get to that point at 12? Rachel, do you see why we're going 2 to the right now? Because that's where the 12 is. Does that make sense to you, Rachel? Okay, so that's what we're going to do. We're going to say it's 2 right. So I'm going to go ahead now, and I'm going to write my cosine equation. So y equals, the a is 4.5, cosine pi over 5 x minus 2 plus 7.5. Okay, with the limited amount of time that we have, I'm going to go back up so you can see the data in the table. I want you to go ahead, and I leave that up there for you. I want you to go ahead, hall pass, Isaac, and both you and Janaya, it's like 5 minutes to the end of the class. Can you just hold a minute and just sort of let us finish what we're doing here, please, Isaac and Janaya? It's right. It's just 5 minutes before we end the class. Okay. So, excuse me. So, can I get you to take these values, put them into the table, like we just did? And one of the things you're going to notice this time is that as you're putting the x values into the table, you can use that feature where Desmos is suggesting what the x values are going to be, because once it sees that you put 0, then 1, then 2, then 3, then 4, it's going to say, oh, looks like you want to go up by 1. So go ahead and allow Desmos to enter those values for you, right? And then enter your cosine equation and make sure those two things match up. I'm going to give you a few minutes to do that. And then I'm going to ask if one of you wouldn't mind sharing your graph along with your equation with the class to see if everything, make sure it matches up first, obviously. Make sure that those tables, the table you're putting in matches up with the equation that we're putting in. Now, is that every point is going to be, well, I designed this one so every point would match up. But that's not always going to be the case. I'm just warning you about that. In this case, it does match up exactly. But that's not always the case, certainly not in the real world when you're collecting data. So could you all quickly do that? And I'll wait a few minutes. And before we finish, I'm going to ask one of you if you wouldn't mind sharing your thing with us. Jeremy, if you could just put what you have to say in the chat for me, please, because remember, I'm trying to avoid recording anybody's question because that's the master's not to do that. So just put your question in the chat for me, please. May I share? Okay, so you can just give me a minute because I'm gonna have to release my sharing with you. Is everybody else okay with us taking the numbers off the screen? Have you got all the numbers into your Desmos at this point? All right, I just want to check with the room here. Really says no. Okay, so I'll wait. Oh, got a lot of no's here. All right, so I'm gonna leave this on the screen for another minute. It's 2:37. We're almost at the end. So let me give you a few more minutes to get your data in, and then we're going to let Jeremy share what he has and see if those things match. By the way, Jeremy, did it match up nicely? Can you let us know at least know whether your equation and your points matched up. Okay, so he says yes to that. Okay, all right. All right, let me erase some of this so that you can see the table a little better. And on a doing a sine function, we will eventually, and we're running out of time, so we may not be able to actually do this in the meantime, Jeremy. Put in what you think the relevant sine function is, and make sure both functions are doing the same thing. So come up with a sine function quickly and drop that in, and then we're going to ask you to share your screen with the class. Okay. All right. So I'm going to end my sharing and my recording.